Hello guys, this is the map tutor and in today's video I'll be solving this problem. We have a cyclist who is going in a straight line at a uniform velocity. That means the acceleration is zero, and the velocity is equal to 27 kilometers per hour. And the resistance force can be expressed with this expression where k is zero point 0.3, assuming that the unit of velocity is meters per second. So we must change these units here, multiplied by 1000 over 3600. That is 7.5 meters per second. That's the speed. And the mass of the cyclist is, and the bicycle, the total mass is 70 kilograms. But that is not relevant because if we do a diagram here, we draw a bicycle. Let's draw a bicycle here. Alright. Something like this. Alright, a bicycle. When we draw the forces, we will have normal force perpendicular to the surface. We'll have the force of the wave. We will have the force of the bicycle of the cyclist. There will be a resistant force. But because the road has no slope, the mass will be not relevant in this problem. Because if we sum all the forces in the x-axis, we will notice that there is motion, so it's mass times acceleration, but the acceleration is zero. So the mass will not be relevant. This will be equal to zero. And the only forces acting on the x-axis will be the force of the cyclist and the resistance force. So the force of the cyclist is equal to the resistance force. And we have an expression for that. It's k times velocity squared. And we replace those numbers. We have 0.3 times velocity squared, 7.5 meters per second squared. And in the problem it should say that the unit of this k is kilograms, because the result here will be newtons, and we need this to be newtons because it's a force. Well, we can put that, and the answer of that is 16.9 newtons. All right. The next question is to find the work done by the cyclist if it traveled a distance of 1.2 kilometers. So the work is basically the force times the distance moved by the force, the direction of the force. So replacing that, we got 16.9 newtons times the distance, 1,200 meters. And that is basically 2.3 kilojoules, which is 20,300 joules. All right. We also have to find what is the power of the cyclist. The power is the derivative of the work. So let's do that derivative. And we know the work is basically the force times the distance. And we do this derivative. And the derivative of function distance is the function velocity. So this will be basically force times velocity. Right? If we substitute the value of force in this formula, we have the force is 16.9 newtons times the velocity 7.5 meters per second. That is equal to 127, and the unit of power is watts. Then the next question is, what is the highest velocity the cyclist could achieve with a fixed power of 600 watts? We can use the formula. We know the power is 600 watts, and that is equal to a force and a velocity. But the force is equal to k times velocity squared. So we have k times velocity squared times velocity. That is k times velocity to the cube. So we are looking for velocity. So we clear the variable velocity, and we find that velocity is equal to the cubic root of 600 watts or 0.3. And we put that on the calculator. So the velocity will be equal to 12.6 meters per second. And that's the velocity in the final question of the problem.